In this video, we're going to talk about how to solve square root equations. So square root equations are equations that include square roots. You can solve a square root equation by squaring both sides of the equation after isolating the square root. So for example, if we're working on solving the equation the square root of x minus 5 equals 7, we can go ahead and square both sides to undo that square root, because you can see in this equation the square root is by itself on one side of the equation. So when we actually go ahead and square both sides, we're just going to end up with a linear equation that we can go ahead and solve using opposite operations. So it's very, very important to keep in mind this idea of isolating the radical first, because if you don't isolate the radical first, that can lead to some algebra mistakes, and it can also lead to a more complex equation to solve. So for example, if I'm trying to solve the square root of x minus 2 minus 1 equals 5, notice that this square root is not isolated because it has this extra term, this minus 1 term with it, okay? So if I were to just go ahead and square both sides, I'd be squaring all of the square root of x minus 2 minus 1. And a common mistake that I see is a lot of people will rewrite this as x minus 2 minus 1, but that doesn't work because that minus 1 is not under the square root. Okay, so when you're working with square roots, always keep in mind that idea of whether things are on the outside or on the inside. So actually, if you're just curious to know how would I expand the square root of x minus 2 minus 1, you'd actually have to use FOIL. So the first term would now become the square root of x minus 2 squared, so that'd be x minus 2. Then you'd have minus 2 times the square root of x minus 1, and then you'd have plus 1, and then on the right side we still have that 25, right, from squaring both sides. So notice that this is a more complex equation to solve. I mean, you can solve it, but it's more complex. But if you use the method on the right, which is what I'm recommending that you guys do, you start off by isolating the square root, right? So what we do is, like, to get rid of that minus 1, we just go ahead and add 1 to both sides. So when you combine those constants on the right, we're going to have the square root of x minus 2 equals 6. So this here, we can now undo the square root by squaring both sides because the radical is already isolated. So when we square both sides, we get x minus 2 equals 6 squared, which is 36, and we can now solve this equation by adding 2 to both sides. So you see, it's much easier to solve if you do that little bit of extra work at the beginning and go ahead and isolate the square root. Okay, so another thing to keep in mind is the idea of extraneous solutions. So remember, we talked about extraneous solutions back when we were solving absolute value equations last semester. Because remember, even if we go ahead and solve a square root equation, sometimes we can end up with an answer that's not going to work when we plug it back into the original problem. So that's why it's so important to always check your solutions. And remember that extraneous solutions are kind of like nonsense solutions, right? You'll end up getting an equation that doesn't make sense, and that's how you know it's extraneous. So now let's get to our problem solving steps that we're going to be using. So you always start off doing opposite operations to isolate the radical, okay? If the radical is already isolated, you can go ahead and skip step 1. Then we're going to square both sides of the equation to undo the square root, and then you'll use opposite operations to solve for x. Remember to always check your solutions and not include any extraneous solutions in your final answer. So let's try with this example. So we have the square root of x plus 4 equals 6. Here I can go ahead and square both sides because my square root is already isolated, right? So when I square both sides, on the left I'm left with x plus 4, and then on the right I have 6 squared, which is 36. Now all I need to do is solve for x, and I can do that by doing the opposite of plus 4, okay? So that's minus 4 on both sides. And then I end up getting x equals 32. Remember, I can't say it's my answer until I've gone ahead and plugged in and checked. So I have the square root of 32 plus 4, right? All I'm doing is substituting in that value for x, and I'm checking if that's equal to 6. Well, that's telling me that the square root of 36 is 6, which is in fact true, so 32 is the correct solution. Now let's go ahead and try this example. Well, in this case, we don't have our square root isolated, right? We have this extra 5 there. Since that is a positive 5, I'm going to go ahead and do the opposite and subtract 5 from both sides of my equation. When I subtract 5 from both sides, I have the square root of x minus 3 equals 9 minus 5, which is 4. Now that that square root is isolated, I can go ahead and square both sides. So when I do that, I get x minus 3 is equal to 4 squared, which is 16. Now to get x by itself, I'm going to go ahead and do the opposite of minus 3, and I'm going to add 3 to both sides. When I add 3 to both sides, I get x equals 19. Let's go ahead and check x equals 19 by plugging back into the original equation. So I have 5 plus the square root of 19 minus 3, and I'm checking if that equals 9. So that's 5 plus the square root of 19 minus 3, so that's 16, and that's equal to 9. So that's telling me that 5 plus the square root of 16, which is 4, that's equal to 9, which is in fact true. So x equals 19 is the solution to this problem. Now you can go ahead and pause the video and try doing this example on your own. So here, once again, we have a square root that is not isolated, so we're going to start off by getting rid of those extra terms. So the extra term I have is that plus 4, right? So I'm going to do the opposite and subtract 4 from both sides. When I do that, I get the square root of x plus 2 equals 3, which I can undo by squaring both sides. So that's going to give me x plus 2 equals 9, and then I subtract 2 from both sides, which gives me x equals 7. It does work when you plug it back into the original equation, so x equals 7 is the solution. So now let's try this example. So this is a little bit different because we now have a variable on the right side of our equation. But the steps are always going to be the same. You always want to isolate the square root. Okay, so this minus 3, I'm going to move it to the other side so that it's away from my square root. So I end up with the square root of x plus 5 equals x plus 3. Now I can go ahead and square both sides, but when I square both sides, on the right side, what's different here is I'm going to be squaring a binomial. Okay, so remember here, this x plus 3 squared is not equal to x squared plus 9, right? So we're not going to do that because we know that when you square a binomial, you have to use FOIL or you have to use that special factoring pattern, right? So you can do x plus 3 times x plus 3 and then use FOIL. I actually personally prefer to use that a plus b squared equals a squared plus 2ab plus b squared, because to me that just feels a lot quicker. Okay, so if I use that, this right side is going to turn into x squared, right? Because a is x. 2ab is going to be 2 times the product of these terms. So I have 2 times 3 times x. So that's going to be plus 6x. And then I have plus b squared. So 3 squared is going to be 9. On the left side, squaring that square root is just going to undo the square root. So I have x plus 5 equals x squared plus 6x plus 9. So now I want you to look at this equation for a second and think about how it is that we're going to go about solving for x. Hopefully you looked at it and recognized that it's a quadratic equation. Okay, so remember in a quadratic, when we use our solving methods, we usually want to get into ax squared plus bx plus c equals 0 form, right? If we get it into standard form, we can do quadratic formula or graphing or factoring. We can use one of those methods to solve. So in order to get this equation set equal to 0, I'm going to move the x plus 5 to the other side. Okay, so I'm just going to do the opposite of x, so minus x, opposite of plus 5, and subtract 5. Remember, anything I do on one side, I'm going to do on the other. So I'm going to subtract x and subtract 5 from both sides. On the left side, that's all going to leave me with 0. And then on the right side, I have x squared, and then I have plus 6x minus x. So that's going to be, well, that's basically a 1, right? So 6 minus 1 is going to be 5. So plus 5x, and then plus 9 minus 5, which is 4. Okay? Now you can solve this using your favorite quadratic solving method. I personally prefer factoring, so I'm going to go ahead and factor this because the two factors that multiply to 4 and add to 5 are x plus 1 and x plus 4. Remember, the zero product property tells us that we can now say that x plus 1 equals 0, x plus 4 equals 0, and when you solve these two linear equations, you'll get x equals negative 1, x equals negative 4. Well, we always need to go back and check our solutions in our original problem, right? So we go back to the original square root of x plus 5 minus 3 equals x. And I'm going to start off by checking x equals negative 1. So I get the square root of negative 1 plus 5 minus 3 equals negative 1. So that is telling me that the square root of negative 1 plus 5, square root of 4 minus 3 is equal to negative 1. So 2 minus 3 equals negative 1, which is in fact true. Okay, now we're going to try x equals negative 4. So we have the square root of negative 4 plus 5 minus 3 equals negative 4. So that's telling me that the square root of 1 minus 3 equals negative 4, which is saying that 1 minus 3 equals negative 4, which is not true, right? That is complete nonsense. So that means that negative 4 is an extraneous solution. Okay, so that means that x equals negative 1 is actually the only solution to this equation. So always be sure to go ahead and check your solutions because sometimes extraneous solutions do occur in these problems. Now you can go ahead and pause the video and try doing this example on your own. So in this one, even though we have a variable on both sides, the square root is already isolated, so the first step is to square both sides. When you square both sides, you get this quadratic equation, and then I'm going to set it equal to 0. Once again, I solved this by factoring, but you can graph, use the quadratic formula, do whatever makes sense to you. When we solve this now, we get two solutions, x equals negative 7 and x equals 1. When I plug them both back in, notice that the -7 is telling me that the square root of 25 equals -5, which is not true. So I'm going to go ahead and eliminate that -7, and so x equals 1 is my only solution. So remember, to solve a square root equation, remember to always first isolate the square root using opposite operations. Once you've isolated the square root, use opposite operations to solve for the variable. Remember to always plug in and check your solutions to see whether you have any extraneous solutions.